No, 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 no. It is it is new people. It is Michael Petru. Right. Menthol is usually epoxy resin. They were probably not informing you precisely, but this technology was used for creation some helicopters doors for Israel army. Yeah. If probably not necessary to have other questions, therefore once more, big hand for him.
Okay.
I must request Professor Militki to kindly give a memento to Professor Michael Petru. Yeah, it is coming. May I request the people sitting at the back to kindly move forward a little? You will probably be able to connect a little better. Thank you so much.
Yeah. Okay, second presenter is well-known specialist Professor Mishra. His team is 3D spacer knitted fabrics for multifunction applications. It will be a little bit connections with this 3D system being discussing in frame of presentation of Professor Václavík. Therefore, we will see now another kind of 3D. Be so kind and start.
Thank you very much, Honorable Chairman, Sir, Professor Militki. Very good afternoon to everyone. Yeah, so ultimately we come to another kind of 3D textile structure. This time it is produced through knitting. And they are same structures as Professor Václavík was explaining in the morning session or in the first session, but spacers are produced by weaving, as he explained. Also, Dr. Ghanshyam was discussing very intensive mechanical properties about composites created from woven spacer fabrics. But now we will discuss about some other kinds of spacers, relatively more well-known to automotive industry, and they are produced through knitting. And they have very big distance, relatively big distance between the upper and lower layer of fabric. That is why they are very good with respect to cushioning application. Well, this is only some collection of research outputs from one of my previous PhD student. Now he is Dr. Veera Kumar from India, of course. So at Liberes Technical University, we work jointly with industries dealing with technical textiles and automotive components, because car Skoda is originally having big company in Czech Republic, and not just Skoda but all world players of automotive sector, they need a lot of spacers and textiles for seating and other interiors of the car. So though conventional textile industry is not existing in Europe as a whole, but technical textiles, just like spacer fabrics for automotives, are quite developed and still prospering. A little bit reviving or explaining what all these 3D textiles are and how are they characterized or how are they different from standard textiles because of their dimensional shapes, because they can be they can be characterized due to their very high thickness or the third dimension. Standard woven fabric is just like a piece of paper, flat sheet, a film of polymer, of course not with respect to micro structure or geometry, but can be comparable to some sheet. On the other hand, three-dimensional textiles, in terms of textile terminologies, are those which have substantial third dimension. They can be produced, as explained by Professor Behera, as very good reinforcement for composites. They are solid structures and sometimes hollow structures as spacer fabrics. These knitted spacers can be produced by both principles of weft as well as warp knitting. Of course, we need a double jersey weft knitting, and in case of warp knitting, necessary to have a Russell principle. The fundamental structure of a woven or knitted spacer is like this, as shown in the picture. Very huge pores, like honeycomb, can be honeycomb shape, can be other geometrical shape, but you can see the pores are relatively very, very big. And the thickness, the distance between the top and bottom layer can be as high as 6 to 7, 8 centimeters. Minimum can be a few millimeters. Depends on end use application and properties, what thickness is important for us. They have many advantages compared to woven spacers, but on the contrary, if we are looking into reinforcement to composite, we need dimensional stability, and that is there in woven structures. Everyone knows weaving is one of the most versatile technologies to produce robust, durable, tough, yet flexible geometries, and they can be used in reinforcement of composites. On the other hand, knitted spacers are not good for composites. Well, they can be used. I don't deny they cannot be used at all, but not so good with respect to load bearing. But they have extraordinary compressional resilience, transmission related properties, and that is why they are very widely used in automotives, especially in car seats. In recent times, modern car seats use this in place of foam, because the major drawback of foam is not so high level of compressional resiliency or recovery to compression. It can be produced by double jersey weft knitting, warp knitting. People familiar with knitting principle and knitting industry are quite familiar with what type of machine is required. So warp knitted spacers are more widely used because they are more robust, relatively more robust compared to weft knitted structures. Second, very big area of application of such knitted spacers are in sports shoes. All kinds of sneakers, sports shoes, they use spacers. Please look into your sports shoes today. You will find spacers all around your foot. Why? Because of the compressional cushioning, the comfort required for the sports activity. Running shoes, breathability, because they are breathable, they allow air to pass in and out. They are able to transmit the water vapor or the moisture vapor through sweating, which we generate during intensive physical activity like running, like sports, playing football, etc. There are many possibilities of manipulating the geometry. The critical element in knitted spacer is the spacer yarn or the spacer filament, because the top and bottom layer is interconnected by the yarns. And obviously, it's a filament yarn, not spun yarns. Spun yarns are not so good as linear springs. What we desire from this connecting spacer yarn, so this is top layer, bottom layer, and spacer yarns. Spacer yarn should behave as a spring. It should bend, buckle, but recover. And that is typical characteristic of synthetic filaments. And monofilaments are much better than multifilaments. There is a lot of research work, not just by us, but by similar research groups who have optimized what kind of yarn dimension with respect to denier, with respect to number of spacers per unit area are most suitable for some specific application. As I said, the thickness or the distance varies from few millimeters, like 2-3 millimeters, to 6 centimeters. What are these 6 centimeter space distance fabrics are meant for? Not for shoes, but for cushioning of bed cushions. Highly comfortable bed cushions are made from spacers of thickness 6 to 7 centimeter in place of foam. They are used as shock absorbers in military vehicles when they do some military vehicle testing in defense laboratories. They need a lot of absorbents of mechanical shock, and they use these very high distance knitted spacers. They are used for lightweight shelters, makeshift shelters, with some covering of these pores, used as screens. In some composites, definitely. In some geotextiles, where this porosity is quite helpful to hold the soil together, and erosion is avoided. They are used extensively in sports, not just for shoes, but for many types of garments. The typical advantage of this porous nature of spacers is transfer of air, transfer of water vapor, and that is critically desired in activities like sports. And in car seat as well, it is necessary that the seat is breathable. The body heat is transmitted, or it is protected. The possibilities of engineering such structure lies in orientation of the spacer yarn, definitely the construction of the fabric, starting with spacer yarn and the geometry of the layers in top and bottom layer, the compactness or the tightness or cover factor, the GSM, the stitch density or loop density. Well, these loops exist only on the top and bottom layer, but not in between. In between are only filaments. These filaments or the spacer elements can be perpendicularly placed, can be with some angular disposition, can be in zigzag fashion, and based on these geometries, these angles, their compression related properties, shear related property, tensile related properties, everything is variable, and we can tailor make such structures. They have, as I said, excellent recovery to compressional deformation. They are breathable, that is why they are very good cushioning material. Because of their spring-like behavior, and they can transmit moisture. If we study the compression curve of a spacer fabric, we come across 3 distinct zones, as you see in this kind of graph. Here is stress strain or compression. Initially, there is no deformation. Here is no strain with some. There is deformation, but no stress, and there is a elastic part. After some peak, there is again some plateau, and then there is densification. In this densification state, the porosity decreases, the structure becomes more compact, and there is the peak. And when the load is released, the recovery is as high as 99%. So this kind of spacer knitted structures have very good cyclic recovery property. That is why they can be used in cushioning, like automotive seats. They have lightweight, very light. Compared to foam, they are quite lighter. So energy saving is tremendous in automotives and in all sectors. They are used not just for shoes, car seats, but for some kind of pads, some bandages, globes, some vests, especially for absorbance of mechanical shock. So before conducting this research, we did some literature survey, what other people are doing, and we found a lot of interesting outcomes from different parts of the world. And we were convinced, and we successfully proved that these are very good replacements, not just for foams, but some rubbers, bubble, films, airbags in many application areas. Some people studied their compression transmission related property, and we collected samples from industry, our industrial partner, not just in Czech Republic, but in UK and in Germany, who supplied varieties of weft knitted and warp knitted structures based on our recommendation and specifications. Some special weft knitted spacers can be designed and created using small amount of lycra or spandex on the surface layers, because as is well known, spandex is very good with respect to elastic recovery, and not just compressional recovery, but elastic recovery is enhanced. Through our study, we concluded warp knitted structures are better with respect to compressional resilience and energy absorption capacity compared to weft knitted structures, and they are dimensionally more stable. However, in the beginning, we tried to investigate the influence of structural parameters for such weft and warp knitted fabrics on their end use mechanical, thermal, and similar properties. From mechanical point of view, it is very important to identify what sorts of deformations come into picture when these fabrics are used in real life situation in car seat. The occupant of a car seat may be a driver or the passenger. Why just car, but any automotive? If you are sitting in a bus, we have vertical movement, lateral movement, and this shear, as is several times pointed out, is very important mode of deformation, not just in these, but in all our practical life, even in clothing, in composites, in house building. The tangential deformation which comes into picture due to loading and subsequent recovery is very important to decide how robust is the structure, if it is able to survive this kind of stresses, and what is the peak stress level it can survive. And in spacers, typically, because we are looking into automotives and sports shoes, if you are running, playing football, imagine how many deformation modes are coming into picture on your foot. Compression, shear, tensile. So we did extensive evaluation of in-plane shear. There are two modes of shearing, only across the plane, that is in plane, and in between plane, that is out of plane. In plane shear is relatively easy to measure, because in textile it was not so popular to use this method, but in other material sciences, they have some method based on picture frame, some frame as a rhombus, where you can fix the sample and use tensile loading. Because of the fixture, the load is distributed into the edges, and you get a shear deformation. So we modified that picture frame method to be adopted to textiles. There is limitation always, because textiles, as I said, are quite interesting structures, have tendency to buckle. Buckling is very, very common in textile yarns, fabrics. So it is very difficult to regulate the shear deformation when buckling occurs. That is why it is essential that you precisely control the deformation only till point of buckling. Of course, it can be done by some camera vision, which is interfaced with the tensile testing device. But out of plane, when we talk about shear between planes in textile, is very complex. In standard textile is almost, as of now, I cannot find any method which can be used. When it is little thicker is possible. Well, 6 centimeter is one extreme. Not in all cases we use 6 centimeter thick spacers. Standard spacers used in shoes are 5 millimeters. In car seat, 1 centimeter. It is very complex to regulate the deformation, tangential deformation in such small thickness. So we decided we restrict our investigation as of now only through in plane and compression acoustic. In modern society, acoustic is very big problem because in such theater, in a big crowded atmosphere, there is a lot of noise inside aircraft, and we need means and measures to absorb unwanted noise. And porous structures with not just porous but well-defined porous channels, materials having porous channels are very good sound absorbents. So we want to investigate how far these spacer fabrics can replace the existing sound absorbing materials. It is not essentially just used for sound absorption, but it is one of the additional advantages you can obtain from such structures if you want to use it in building interior. We studied acoustic properties because we are using it in automotives. There is huge amount of noise in and out of the automotive. And thermophysiology is very important in all human-related applications. In order to measure, investigate the in-plane shear, such a setup is necessary. We were able to modify the principle of picture frame because while fixing the textile sample, it is necessary to have 4 small cuts at the corners so that it doesn't buckle before it attains the peak shear stress, and a square piece of sample when subjected to tensile loading on an instrument device deforms into this kind of a shape, and just before the buckling starts, we can stop the measurement and we can plot shear stress with respect to shear strain. And with governing equations, we can find what is shear rigidity. We adopted one image analysis based technique to characterize the deformation on shearing mode with respect to shear load, and 1 year back it was published in Journal of Industrial Textiles. When we talk about car seats, it is necessary to investigate how efficient are these with respect to compressional absorption of compressional energy and recovery from compressional deformation. It can be very easily conducted on tensile tester, universal tensile tester by changing the clamps, as you can see in this picture. We theoretically calculated with respect to acoustic efficiency or sound absorption efficiency. It is necessary to determine how complex are the pores in the structure, because the sound energy needs to follow a very complex path and gets confused, and then it is absorbed inside the structure. Very simple instruments are used in the laboratory to measure sound absorption efficiency. It's known as impedance tube. You can have a sound generator, you can have a receiver. If there is sample, there is less amount of sound received on the receiving side, and we can calculate at different frequencies what is the efficiency of noise reduction. We calculate noise reduction coefficient. As I mentioned in the beginning, they are very good for transmission of water vapor, but if you are looking into thermal insulation, please note that for thermal insulation or protection against heat loss, it is necessary to have micropores, very small dimensions of pores, not just huge amount of air, but air distributed in smaller pockets and in closed geometry, so that the energy is not transmitted out of this chamber, small pores. On the other hand, for sound absorption, you allow the sound to pass through very complex path, not being restricted in one position. Not going into details of such principles, I must mention here that thermal protection of these very open structures are not so good as individual layer. But in practical cases, when we are making heat protective clothing, we use multiple layers of textiles. Outer layer, middle layer, which is the active one, inner layer, and all of them have different functionalities. The innermost layer is very more close to human body, needs little bit surface comfort. It should be hydrophilic to absorb the water droplets or sweat which is generated. And the middle layer is responsible to transmit the vapor and liquid water to the outer layer, and outer layer needs to transmit it to the atmosphere. All of them are created from different types of fibers, different geometries, different structures can be knitted, woven, etc. But if we want to use such spacers, they can be used only in the middle layer, not next to skin, or not as independent single layer material for thermal protection. So let us not consider for thermal protection these kind of structures. Okay. From our results, we found very significant influence of the structural parameters, but most essential is the dimension and distribution of the spacer yarns. When we talk about bulk property, it is definitely dependent on the intermediate yarn, not on the yarns which are existing on top and bottom layer. Because the overall thickness, out of overall thickness, 90% of thickness is due to this spacer yarn, and 5% is just the thickness of the inner and outer layer. So if you change the parameters of spacer yarn, you can very significantly change the bulk properties. With respect to shear, again, the density of yarn in unit area or space, unit volume, plays very crucial role in deciding how resistant it is to deformation in the angular mode or the tangential mode. Not only resistant, but how resilient. Some structures can allow deformation, but they can recover quite fast, and that in some cases are quite desired. Lot of statistical analysis is done on such results, and we concluded significant outcomes. All are published in some textile journals. If you are interested, just Google spacer knitted textiles, Technical University Liberec, and you will find these articles. We will be happy to interact with you over email or through discussion to further cooperate in such areas. Some study of noise attenuation or sound absorption efficiency was published in Textile Research Journal. I must conclude in the end that spacer knitted textiles have been existing, but in current time or recent time, we have extensively studied how advantageous they are and which particular internal structures, constructional parameters are important or more dominant to decide their compressional, shear, or tensile related performance. Warp knitted spacers are very widely used in the automotive sector, but in other military and civil sectors, like as I mentioned, in construction, in soil protection, in future they will have more market or more acceptability in our society. We are not, this is not everything or the ultimate level of understanding. Still, we are continuing with varieties of spacers used as components in sandwich textiles, where we use such spacers as the middle layer in between woven fabrics, and we are trying to use them as some kind of lightweight material for containers or big trucks. The container can be made from such spacers made into lightweight composites when they are sandwiched between relatively robust fabric structures. Thank you very much. And maybe we can have discussion if it is allowed.
Yeah. If you have some questions, be so kind. It was probably too comprehensive for discussion, and there were discussions before. Therefore, once more, big hand for him.
Thank you.
Thank you, Professor Militki. Thank you, Dr. Mishra.
And now, maybe time for lady. Therefore, Adin Gerike from Stellenbosch University, South Africa, will have a very inspiring speech about some comfort properties of home textiles in South Africa conditions. Therefore, we'll see there are similar conditions as in Delhi, therefore probably will be interesting for all of you.
Right. Good afternoon, ladies and gentlemen. Thank you very much for the invitation, first of all, to come all the way to India to speak to you. I think before I start, I should maybe just give you a little overview of where I come from. Is this better? I come from the University of Stellenbosch, which is situated right at the root of Africa in a town called Stellenbosch. It's about 50 kilometers from Cape Town. It's in the heart of the winelands, so we make wine as well as study textiles there. The university celebrated its centenary this year. We've got about 32,000 students, of which 4,000 are international students, 100 of them from 100 different countries, about 3,500 staff. And Stellenbosch positions itself as a leading research-intensive university in Africa. Stellenbosch University is one of the best in South Africa, and the Department of Chemistry, where I come from, is also rated very highly. There's a few pictures of our campus. Now, the program in textiles is housed in the Department of Chemistry and Polymer Science. And this program was started in 2003. And it's unique in its nature in its sense that it's actually a BSc degree in chemistry and polymer science, but we also allow the students to do textile science as a subject. So we try to create a chemist or a polymer scientist with textile knowledge instead of the other way around. This was when we started this in 2003. It was fairly new, and today we realize it was the right way to go in the complex South African textile industry situation, with the problem of imports. Just producing commodity textiles is not viable anymore, and we should focus on value addition and niche markets and functional textiles, etc. Now, I was asked to talk about home textiles in South Africa, and I thought it might be wise to just give you a little bit of perspective of the South African industry, or of South Africa as such, for those of you that haven't visited yet. Let me just move this thing slightly, like that. Okay. For those of you that haven't been there, South Africa's got about 56 million people, which in itself gives you quite a substantial market for home textiles, specifically beds and bedding. The country has got a fairly moderate climate. It's divided into 6 climatic zones, of which only 2 can be described as extreme winter or summer temperatures. The rest is fairly moderate. We've got winter night temperatures of about 4 to 7 degrees C and summer nights of about 15 to 21. As a result of the above, a very small percentage of houses have air conditioning. I myself have never lived in a house with air conditioning. So our bedding and bed textiles must accommodate the range in temperatures that might be expected, providing quite a challenge in selecting the right combination of bed covers. Now, in South Africa, we still base... Oops, there's something wrong there. Now, the main type of bedding still preferred is a duvet, although all of us doesn't have a luxurious setup like on the picture. And apart from durability and aesthetics, the main purpose of bedding is to create conditions suitable for the enhancement of optimum rest or sleep. So that's what I want to focus on. And providing these customer needs in the conditions I described is, as I said, quite a challenge and something that is often underestimated. Okay, so durability and aesthetics, I said, is important, but our focus will be on the following. So I thought I was wondering what I could tell you today about the South African scene that you might not know, and I thought I'll focus on three things. First of all, thermophysiological comfort, which has to be provided in the descriptions. But the next thing is also something like protection from, well, biting insects. There's nothing that can disturb a comfortable night's sleep more than a mosquito or a bedbug or a flea or whatever. So I'll focus on that as well. And then lastly, psychological satisfaction is also an important part of comfort. If your clothes doesn't satisfy you on a psychological level, if you don't feel good in it, you are not going to feel comfortable. But the opposite is also true. So I'll talk about cultural traditions and specifically blankets in South Africa to end the talk. Okay, thermophysiological comfort and sleep, let's quickly go over that. Sleep is strongly related to this thermophysiological regulation of the human body. And in clothing, we define comfort as being totally unaware of what you are wearing. It can be described as freedom from pain or freedom from discomfort. And this multidimensional phenomenon includes subjective responses from a large number of stimuli, from the textiles that are touched, as well as from the external environment. Now, if we think of our clothing situation, we've got our clothing surrounding the body, and we've got heat generated by the body, and this heat must go through the clothing to the environment. At the same time, the environment is sometimes providing heat, and this must now again go through the clothing to the body, right? If this doesn't work, we start producing sweat, insensible or sensible perspiration, and moisture will form between the clothing and the body. Now, this moisture must also go through the clothes to the environment. If it doesn't happen, we've got liquid moisture formation, and this leads to a wet garment, which is uncomfortable. Now, the same principles apply to a body covered by a duvet or covered by bedding. The main thing here to consider is the microclimate that now forms between the duvet and the body. Now, this microclimate is important to control, and specifically in relation to thermal regulation, and then, as I said, moisture management. As you fall asleep, the core temperature of your body is reduced through a slower metabolic rate, etc. With this comes a reduction in vasodilatation of your blood vessels under your skin, which causes the blood to flow closer to the skin, which causes cooling or a cooling system where your body now loses heat through conduction or through radiation. And this causes the core temperature to go down. Now, if you want to maintain sleep, you must maintain this low core temperature. But now we go and we cover, this works fine. Nature developed this to work, but now we go and we cover this with a thick duvet or more textiles. And what's more is while we're asleep, the body also reduces its thermoregulation property or process, which causes the whole process to be slowed down. So this places more important emphasis on this bedding system to control the microclimate to keep the body comfortable. Research has shown that about a 30 degrees C, 29 to 30 degrees C temperature must be maintained in the microclimate to ensure comfort. This microclimate is then also influenced by the ambient temperature, as well as the type of textiles that are used to form the layers. In winter, this is not a problem to maintain this because of our moderate climatic conditions. Usually a decrease in temperature can be prevented by selecting the right bedclothes or the right mattress or the right duvet, and a duvet with a value of about 5 to 8 togs is usually enough to provide this comfort. In some areas you might go to 11 or 12, maybe a down duvet, feathers duvet, but usually, as I said, the first option is enough. A new trend in duvets in South Africa is also a double layer one, where they sell a dual purpose duvet, that 2 layers that can be combined with Velcro or whatever to adapt to temperature changes should it be necessary. The summer nights are more of a challenge because here we've got quite a variation and you can't change your bedding according to the weather forecast. Overheating might cause a buildup of moisture. Sorry, that was the previous one. Overheating might first of all, or when your body starts to overheat, it might allow moisture to move through the mattress or through the bedding. But if that is not allowed, then you might find that you start producing sensible perspiration or sweat in liquid form. Now, if this doesn't evaporate, you have a problem. They say that 1 to 2% change in the microclimate, 1 to 2% change in the moisture level of your microclimate can cause a sensation of discomfort. This made us look a little bit closer of what we are actually doing in the bedding scene in South Africa. And I'll summarize it for you briefly. Sorry, I don't want to get there just now. First of all, we would use a duvet inner, and what's usually used there is a range of filling materials from puff balls or hollow fibers for your lower price duvets, microfibers in your middle price class, and then your more luxurious duvets has got feathered down. And nowadays, there's also developments in mohair and even silk inners for the duvets. Now, the next layer, and this you all know, I just want to summarize it to put everything into the picture. Your next layer would be a woven, which can be a polycotton or a cotton, usually a fairly thin fabric, but a trend is to start using a higher count fabric, like even a cotton percale for this, which feels luxurious, but has other effects, which I'll come to now. Then we put this duvet, that's now already in 2 layers, into 2 more layers into the duvet cover. And again, here a range of fabrics is used, anything from 200 count in a plain weave, a polycotton. Nowadays, you also see microfibers being used in a plain weave. And then it goes up to a count of 500, 600, even 1,000 yarns per square inch. The question is, what happens to the water vapor permeability when the interstitial spaces in this fabric starts getting smaller and smaller due to the high fabric count? We did a little study and compared the following. If you look at the first 4 there, those are all the plain weaves. Number 1 and number 3 are the plain weaves that are about 170 to 200 count. And there you see that you still have a fairly high moisture vapor permeability. The second one there is the microfiber. Look at the permeability there. The count was 175, the same as the first one, but the permeability went right down. I'm talking about water vapor permeability. The fourth one, if you look at, okay, those are the 2 counts, but if you look at the difference between those 2, that is both is a 200 and a 230 count, which is fairly small, but the last one is the downproof. Now, that's used in your downproof duvet or your down duvets, where you think you've got a good permeability, but now you use this fairly high count fabric over that, and immediately you've got a reduction. The last 3 in the picture is your satin weaves, where you've got a count of 500, 600, and 1,000. And you can see the lower permeability. So although the customer might be buying something that they think is much more luxurious, got a nice soft feel, you might be compromising the water vapor permeability. Now, if your water vapor permeability goes down, you start producing liquid water, which will wet the surface because you're working with cotton mainly. It's a nice absorption, but you are going to perceive a feeling of discomfort because of the wetness. We also did the following with duvet inners, and we compared a hollow fiber, a puff ball, feather down duvet, and then one with a mohair bat. That's a new development that's just been developed, and as you hear, I'll be going towards the mohair direction every now and again because that's the focus of my studies at the moment. And there you can see the difference in water vapor permeability between the different duvets. Now, all this adds up, and why I'm showing this is that it's important when you plan this and when you don't have controlled air conditioning, that you must use something which allows the most possible permeability to allow for comfort during change in your climatic conditions. The next thing I would like to talk about is biting insects. There's nothing that can interfere more with a good night's sleep than the nuisance of a mosquito trying to feed on your exposed body parts, not to mention the presence of fleas or bed bugs in your bed. This can be an inconvenience, but the same little insects can also inflict dangerous diseases, something like Zika virus, malaria, dengue fever, etc. Especially the malaria is quite a problem in Africa and in some regions in South Africa as well. Now, traditional precautions, oh, there's a few nice pictures for you. Traditional precautions are using mosquito nets, and thousands or hundreds of thousands of meters are being woven or warp netted and sent into Africa and used in different parts of Africa, often distributed by NGOs. The problem with the mosquito net is it's, first of all, quite hard to sleep under, and especially with children, the mosquito net is only effective until the first hole appears or the first opening appears and the mosquito can get in. The other thing that people have to do is to stay indoors after dusk, because that is when the specific malaria mosquito feeds. So all this causes a bit of a problem. Sometimes the mosquito nets are treated with insecticides, which works quite well, apart from alarming footage that you can find on the internet of people using mosquito nets because it's free for all kind of different end users, such as chicken coops, fish nets, wedding veils, you name it. And now this sometimes chemically treated nets goes into the water or the rivers, which is also a source of food, which is not necessarily optimum. We've worked with a company close to Stellenbosch that have been developing a product with a permethrin base that are used to combat malaria in South Africa, but also in Africa. And I'll share a few examples with you. What they do is they developed a spray, first of all, a spray that you can spray your walls, your bedding, your carpet, your curtains, or whatever with, and then also a soap-dry solution that acts as a finish on textiles. Studies on villages where it's been done has given very good results. This is an example of a laundry at a mining company. I think this is in Angola, where the workers' uniforms are all treated with this product, and the number of disease or cases of malaria that was reported has come down quite substantially since they've started using it. The product lasts for at least 3 months. It's not very expensive, and it really works well. The holistic way of treating the problem apparently is where one should go. I don't know if you know the product. Permethrin works on anthropoids. These insects doesn't have a protective shield, a protective enzyme shield around their nerves, so the product acts instantaneously on the nervous system. It's a repellent, but it can also give you the so-called hot feet effect. With other words, when an insect sits on it, it will immediately go away. I wanted to bring you the video, but it's a bit long, the video clip, where we have sent it for testing, and where you can see that the amount of hits, they actually use a mattress or a bottom sheet that's treated, and they put an exposed arm on that, and the number of mosquitoes that actually come close to the arm is reduced like with 80 or 90%, and after 20 washes also by 60 or 7%. So that's your hot feet syndrome, but it's got a double purpose, so it will actually also have the knockdown effect and combine it with a killing factor. The advantage of the product is it's a simple application process, non-yellowing, suitable for most substrates. It's got no effect on the feel and touch of your article. It doesn't affect the moisture management properties. It's user-friendly. It's really easy to apply, and it's got proven effectiveness. And treating a complex problem like this, sometimes want a simple solution or a simple process. This, we are planning to do more studies on this, and it actually works very well. Right, my third topic, psychological comfort. And this I actually put in just more for interest's sake, for you that haven't been to South Africa or doesn't know the country. In South Africa, we've got a habit of using cultural blankets for specific purposes. Blankets are usually regarded as decorative or something that must enhance thermal comfort, but they also play a very important role as one of the colorful elements in our country. And they're included in many traditional celebrations to commemorate life's milestones. It can be said that all the stages of life can be marked and celebrated with a gift of a blanket. From the arrival of a newborn, wedding ceremonies, right through a boy entering manhood, even laying somebody at rest, blankets are used. So one person can go through about 8 blankets at least through a lifespan, given as gifts or bought by himself or kept for might the need for it arise, which creates quite a substantial market for these blankets. Now, I've got a few examples for you. The Abakweta blanket.
Time is or
1 minute. The Abakweta blanket is one used by the Xhosas for the initiation. They go through the whole ritual, paint themselves, and then and they stay in a little hut, and the only thing they've got to protect them from the bush, as they call it, is the blanket. At the end of the ceremony, they all go down to the river to wash, and then the hut and blankets and everything is burnt, and then they get a new blanket to symbolize the next phase. This is the badge of the brave blanket. It comes from the British Empire, where in the 1800s, the British and the Sothos fought together, and this was developed. So it's a combination of British symbols and I've lost the word. The motifs is a combination of British war symbols and the local antelope. And this is given at weddings to celebrate something like the wish to make you brave or whatever. The next one, you can see the cobs and the harvest and health. It's called the Siana Marina, and it symbolizes fertility and wealth. There's an example of women wearing it. This comes from I don't know if you've seen the Black Panther. In that film, they are wearing these specific blankets. Now, anything from a wedding, the birth of a first child, the woman selects her trousseau by selecting blankets for specific occasions, etc., etc. Now, why I'm mentioning this, because of the number of blankets needed for this end use, it's moved towards the mass production market. But the problem is, because it's a psychological thing and it must be correct, a fake does not work. So most of them are still produced in wool. Some acrylics are being accepted, etc. But the market must also understand where it comes from and what is necessary. As I said, often wool and mohair are still used and seen as traditional. You can't reproduce that. Lastly, at the end of my presentation, I just want to refer to natural mohair, which is not so well known in your country, but it's something that we develop in South Africa. It's the focus of my current studies focus on the comfort properties of mohair. It's an amazing fiber. It's got properties like a smooth, luxurious hand, natural luster, smooth, there comes the hand again. It doesn't have crimp, it's got curls. It's got an amazing hygroscopic nature, can be used in sportswear, socks, etc. It's a very good blending fiber. It actually performs better with wool. The scale structure is less pronounced, which doesn't give it the felting property, etc. If you have experience in that or would like to talk about that, you are welcome to contact me later or tomorrow. Yes, and I thank you for your attention.
Okay, thank you. It was first presentation focused on fashion. That's very good because textile is fashion as well. Probably one question of comment, if somebody likes.
Yeah, I have a question here.
Yeah.
This way. You told that in case of permethrin, you are doing it at the washing stage or in the laundry. Whereas we can encapsulate the permethrin on the fabric in the finishing stage on the